previous lecture we completely discussed about single linked list. Okay, so now another topic is circular single linked list. So why we use circular single list is because we don't want to have any null values in the list, and it's easy to traverse. See, now I'll draw this. You see from the lecture, you know, my single linked list is like this. Okay, just single linked list. So this is null. Okay, now what happens here? If I want to traverse, na, I can only go like this. Okay, but if I want to come back, I cannot come back again. From the beginning I have to like initialize my temp variable to head again, and then from the beginning same thing will happen again. Now what happens in the circular single list, right? So what we do here, the last value, so where do we have the null value? Say at the last, so this place, right? So here we have the null value. So what we'll do, this is the right link, we will connect to the first node. The last link we will connect to the first node. So how this is done? Everything whatever we write in the like code of our single linked list, everything is same. Just one thing what we write, wherever we write null, right, there we will write the last, whether, so see, this will be my head, right? So my tail of next will always be my head. Okay, remember, my tail of next will always be equal to my head. So this thing you have to wherever you write, you have to mention. So let us see now, keeping this diagram in mind. So one by one I will explain you few things, or if you I could write here also, but this is better. You can pause and like whenever you want you can pause and write. I don't have to wait for you guys to like see. You can just go back, take screenshot, write it down and go. It's up to you. If you want like understand properly, you have to do something, right? So according to your comfort, do like that. So now okay, so how here while creating a list, okay, there we saw while creating we write like a node new, right? So I'll write that malloc everything, the dynamic DMA. Don't go for DDC or direct memory access. It's not direct memory access, it's dynamic memory allocation. Okay, so new of info, what we did is equals to info, right? But what we wrote new of next, we had written at written as null. So here new of next will be new itself. Okay, new of next, I'll draw that small node. This is my new node. Info is info, but next is pointing towards itself. Okay, there is no null value itself. So this is my creating. Now let us see now. Suppose, okay, now only no nodes are there. That condition I wrote, right? No nodes. Okay, we will see here. If head equals to null, right? Here 2 times. Okay, so what he will do here, no node is there, so he will write new equals to, I mean, see here, okay, new equals to head equals to tail, okay, like that I will write. And here you can mention head of next equals to head itself, head of next. Anyhow, it's not necessary to write, but still it's good to write head of next equals to head. Why? Because we had new of next equals to new itself. So we make a new as head. So if you write, if you don't write this also, you won't be having any I mean effect or changes. But still, this we write for like a good for us to be in safer hand side. Sometimes somewhere small mistake might happen, and while connecting to the, like, suppose if you have many nodes, right? So this is only like here I have. So if I simply leave it like this, so what will happen? If I create a node, now directly this will go and attach to this new. So if I make new equals to head or something, and if I make okay, that's a different scenario where I have to attach this here, and this should come here. But this link, now see here, this link will already be attached to this link. If it is already there exist, this link will attach to this link. So it's better to write like this. Okay, so later, so this is for here you will write that open bracket, close bracket, then here else if. Why else if comes? Only one node, right? So only one node is there, how you attach? So here head, what is the condition? Head of next. Okay, so here head of next, yeah. So here see now, here you cannot write head of next equals to null. Okay, why can't you write? Because in single English we won't be having head values. So what we did here, head of next is head itself. So my existing node here, see here, don't get confused, existing node here. So this is connected to itself. See now, if single node is there, is what, head of next should be head itself. So here what I will write, if head of next equals to head itself, it means one node is present. Now see here, we have this node already present, that is my head node. Okay, so same thing what we did in a single linked list. So there was one node already here. Okay, here it, let's suppose. So this we have to give here, and this we have to give here. So what I will write, new of next equals to head, then head of next equals to new. Okay, from this what happened, new of next equals to head, head of next. Now from here to head itself it went for new, then new equals to head I did. Okay, simple thing. Now suppose new equals to head, so my head is not anymore, tail remains here itself. Okay, now this is insertion at the beginning. Now if I want to insert at the right hand side, what I will do, I will just do this ulta, and here you can say new equals to tail. Okay, same thing happens, head is here already connected to like this. So what I will do, first I will do, suppose it's coming like this, you just have to imagine. So head of next equals to new. Okay, new of next equals to head I have to write, same thing itself, nothing is changing here. Okay, new of next equals to head. So see, same thing is happening here. What you have to do, only the first, if you are writing head of next equals to new in second line, that means it's this head was here and now it is going like this. If you write new of next equals to head in the second line, I just have to switch this. Okay, this will go there and this will come here. Now head of next equals to new first. Let me rewrite it. This was for beginning insertion. In end insertion, I will say head of next, or else better you use tail of next itself. Anyhow, tail of next. Okay, better. Sorry, this is the best way. Tail of next equals to new. New of next. Now don't write tail here. It should be head itself, because you go to the first pointer, right? New equals to tail. Okay, understood, right? So wherever this thing was there, so tail was here, it jumped here, and tail of next or new of next became this. So this was your insertion if only one node is there. Now let us see if many nodes are there, how we will insertion. Same thing is again used here, more than one node. Okay, so sorry, so there yeah, anything, both are fine itself. So now see here, only one node, now more than one nodes. Let me draw a diagram first. Okay, so this is my head here. Okay, and this is my tail over here. So now more than one node is there. So only else part. See, else part, the beginning above part, now else if part, there you don't have to change any one thing, you can write for both beginning, insert at the beginning and insert at the end. So now only in else part we will see. So first else part. Okay, let me write like the above, both things I'll show. So for I will divide, let me divide like this, then else part, this is more good. So this is for beginning, ending, beginning. Okay, I will write beg, and here end. Okay, so now what will happen, see, my node is created. So new of, yeah, I forgot to show this this. Okay, new of next. Now what I will say, new of next is equals to head I will say. Okay, then this is beginning insertion, right? New of next equals to head. Then what I will do, tail of next is equals to new I will say. Okay, then new equals to head. Understood? So what happened here, my node was there, this is my new. So what I did, new of next I made it as my head. So I provided the connection. Then what I did, tail of next I made it as new. Okay, so this my tail ka connection from head it got broke, and this link na it connected over here. Now then new equals to head. So my head was here, then I jumped my head from here to here. Understood? See, simple thing, head went there. Now suppose for end what will happen? Okay, we'll see. Okay, so here my head is here. Okay, so now insertion at the end, my node should be attached here. So what I will write, tail of next equals to new I will say, tail of next equals to new. So this link got broke. Okay, now it went here, my tail is here, tail of next equals to this new. Now new of next is equals to head. Now my this went here. Now tail equals to new. From here I skipped, jumped my tail over here. Understood? Very easy, nothing is there in this. So the same thing like this it is there. So now same thing. Now let us see for deleting. Okay, I will do it fast. So I hope you understood now. So let us see. Okay, so this diagram will keep for reference for time being, but first let us see if only one node is there. Okay, first if there is no node, first condition, no nodes ka condition what, if head equals to null directly, head equals to null directly, then no node, you have to put that permutation, nothing to it. If it one node is there, okay, one node, what is the condition, head of next equals to head, same thing what was there in single English will come, free head I will do, free head I will do, and I will write head equals to tail, head equals to tail equals to null I will do. Okay, understood? For if only one is there. Now let us see if more than one node is there. Now again we will divide the part. So this is the else part, delete at the front. Okay, so now I have to like I said, we have to create a temp variable, temp node star temp. It will be always equal to my head itself. Okay, now coming to this, see now in single English we didn't have a link to the first. Here we had only what to say, tail, I mean we had null, right? So we couldn't provide connection. Let us see now whether the same code will apply, like here whether we can use do it using, like suppose we temp equals to head, right? Suppose temp equals to tail. So if my temp is here, can I provide, can I like delete this directly or like that? So anyhow in single English it's not possible if you think like that. So for some people doubt will come. Suppose my temp equals to tail if I do, so my temp is here, and if I do free temp, can I give any connection directly? So that's not possible. If it was a double English, it is the easiest part. Okay, now see here again. So now what happens, my temp is here now. Now see here, so this connection, now first what I will do, I will send this head to here. Okay, temp of next equals to head I will say. So my head jump from here to here. Now still we have to do something. Now what I will do, my tail of next I will do head, tail of next what I will do equals to head I will do again. So this connection from here it broke. Okay, now it went here. So even two connections are there, this temp. Now what I will do, free temp I will do, free temp. Okay, first I broke the connections everything from this temp. Okay, so temp I made separate. So now after this free temp, this okay temp got, that node got deleted like this. Okay, so now let me redraw this. So here head was there. Now delete from at the end. What will I will do? Same thing I have to write here again. I have to use while loop. Node star temp is equals to head I have to do. Okay, so here what condition I will write, while. Okay, so my tail will always be here now, you know that my tail will always be here. Same thing I will write here again, while temp of next not equals to tail. My thing is I want to bring it at the last second place. Same thing will come here, only one line extra, same as in English, right? And keep okay. So here temp equals to temp of next. Okay, so see here this. Now see, my temp was here. How? Because of this line. Temp of next is not equal to null, true, it will come here. So my temp went here. Now again temp of next is not equal to null, it will went here. Now temp of next is not equal to tail. Temp of next is tail, right? So it will stop here, it will come out of the loop. So my temp is here now, and it came out of the loop. So now what I will do? Now I will say temp of next is equals to head I will say. Okay, temp of next equals to head, or else better what you do, no, it's correct itself. temp of next is equals to head. So this connection, instead of giving to tail, now I took this and gave it like this to head. Okay, so now this tail, what I will do, free tail I will do. So this thing got deleted, so you, automatically this also we won't be having. Now one more thing is left, that is my tail equals to temp. Make sure don't say make tail equals to temp at the beginning. If you say tail equals to temp directly, so what will you delete? You cannot delete anything. So if you declare tail as temp before itself, so if you write free last, so both your temp and tail, so it will be at the same place, right? So temp was here, now here my tail also will be there. If you say temp equals to tail, so this node will have no name itself. So how, what will you put free? In free you cannot write anything itself. Still you can do one thing, you can say temp equals to tail, free temp of next you can say, or tail of next. Okay, anyhow, but see, we already made temp of next as head, so that will become wrong code. So make sure you don't declare a temp tail as temp before. At the end you have to declare tail as temp. So this is for deleting at the beginning, this is delete at the end. Now for display, okay, same thing I will write. Now what happens? So see here, same thing for display. Nodes are temp, I will create here. So I have to traverse. Temp of next is not equal to tail. Instead of tail, what I will write? Head. Okay. So now what will have change here? While temp, okay, this I will write here. Temp of next not equals to head. And for previous thing, temp of next not equals to tail it was. Okay, remember this was for deleting condition to stop at the last second position. Understood? Let me provide this connection properly. This we don't have here. So this is my head. Okay, don't get confused. Now while temp of next, so my temp is here now. So what I am saying, until the temp of next is my head, so my tail is here, I have to traverse. So before traversing, first what I will write, printf %d I will do off. Then here what I will write, temp of info, temp of info. So first my temp ka whatever is there, that will be displayed. Okay. Now what will happen, I will traverse. Temp equals to temp of next. Okay, so now see here, it will displayed here, display over, it will traverse here. Okay, again it will display, it will traverse, it will display, it will traverse. It came now here to this part. Now see here, temp of next is head again, so it will come out of the loop, but we didn't display what is there here. So simply you write again this statement, you have to write this statement again, printf %d comma temp of info or tail of info, anything is fine. Okay, so here again if you wanna the same loop, if you give some changes here, you can again continue traversing. Okay, so this is one of the like advantage, I mean no null values will be there, you can directly again go from here to here, traverse from there to there. So this is circular single linked list. So mostly you see everything was same, only hardly one or two things change. Instead of assigning the last value to null, we just simply said it will go to the head itself. So I hope you understood this concept. We will be seeing the double linked list in the next class.